All right, here we go. So here's the first question, as you saw a few minutes ago. So they're giving, and this one's already got the answer. The answer is no, but let's see why. So 312 is the point. You can't read that well. And then y equals 17x minus 12 is the equation. So I encourage you to copy these down. These will be, I'm doing your exact homework right now. It'll just change the numbers when you get on the Math Excel system. It's going to be the same exact question, even number by number. Like number 1 will be the exact same words for your number 1. It'll just change the numbers. So, and this will be when we're done. I'll ship this out to YouTube. You can get my lectures. I didn't write it somewhere. Off YouTube. Just search my name. Just go to youtube.com. Search. I'm famous on YouTube. No, Brett Heron. The spelling's on the syllabus. And you find our class. In case you missed class, or you just want, if I go too fast, you can go back and you can watch it slower and before a test and all that. So here we go. So how do you answer this question? Determine whether 312 is a solution. What do you do?
Plug X and Y in.
Plug them in. Plug them in. See if it works. Exactly right. So this is X. This is Y. Right? It's always alphabetical. X comes before Y in the alphabet. Plug this in for X. Plug this in for Y. And simply work out the two sides and see if they're equal or not. So 12 equals 17 times 3 minus 12. Does it? I don't know. Let's see. 3 times 17, what's that? 51 minus 12. You use a calculator for homework tests, everything.
39. 12 is not equal to 39.
Is that what it is, 39 over there? Yeah, so that's not true, huh? So that's why the answer is no. So that's just a plug-in. They're starting real simple. They're just saying, hey, just plug the 3 in for X, the 12 in for Y. Find out if they're equal or not. And the answer is no. So I'm going to flash off of that again. Okay, so this chapter, we're starting off with chapter 1 is just review. We don't need that. So we're diving right into chapter 2, which is graphs. So y equals 3x minus 6. Let me write that a little bigger for you. Y equals 3x minus 6. We're going to graph it. I'll show you how to do the little graphing thing. It's real easy. But first off, how do you even make a graph of something like 3x minus 6? Let me do it over here. How do we do it? Does anybody remember it? First off, what kind of graph is it going to be? I mean, is it going to have curves in it? Is it going to be like a circle? Is it going to be a U shape? Is it going to be a straight line? What's it going to be?
Linear.
It's what?
Linear.
It's linear. It's going to be a line, in other words. How do you know it's linear and going to be a line?
Because it's
What is it about an equation, when you look at it, that makes it linear and not like a U shape or have any curvature to it? It's the fact that these guys are first power. If the letters are first power, it's a line. It's going to be a straight line. If they were squared, if it was like y equals 3x squared, that'd be a U shape then. So it's the higher powers that make things bend, that brings curvature into graphs. So anyway, we're not going to do those for like a month or two. For now, everything's going to be straight lines. So this is a straight line. Just got x to the first, regular x, regular y. Straight line. Okay, so we know it's a straight line. Well, that's helpful. If you know it's a straight line, you only need 2 dots, right? If we can just get our hands on 2 dots, connect the dots, we got the line. So, okay, how do we find those 2 dots?
well, you know the slope of the rise of a run is going to be 3 over 1.
Right? And we do that second, though, right?
Then the y-intercept is going to be -6.
Yeah, so we start there, don't we?
-6.
Yeah, so start right here with this number that's at the back. That's where you start. That is the y-intercept, meaning that's down, because it's negative, down 6 in the middle. So meaning you go to the middle and you go down 6. So 1, 2, 3, 4, 5, 6. Right there at down 6 is your first dot. So whatever number is off here to the right with his sign is where the first dot is. And that's always on the middle line. We call it a y-intercept because this is the y-axis, right? This one's the x-axis. So we call this dot a y-intercept. It hits the y-axis. So if that was plus 6, then it would be up 6 from the middle, wouldn't it? Okay, that's our first dot. Now how do we get the second? You all were saying it?
You go up 3.
Yeah, it's that slope right here in the front of x. If it's a whole number, put it over 1. Why? Because 3 over 1 is the same as 3, isn't it? We do that all the time. We always stick it in 1s everywhere whenever we need another number, because that doesn't change it. Why couldn't I just stick in a 2? Well, because 3 halves is not the same as 3. But 3 over 1 is the same, right? It just looks different, but it's not really any different. 3 divided by 1 is still just 3. isn't it? So that's just a fancy 3, so I haven't really changed anything. We do that all the time in math. I call it plastic surgery, just to say something weird to help you remember. It's like we're removing the wrinkles, we're making it look different without being different. We do that all the time in math. So that's still a 3, but now we have the two numbers which we need to do the slope thing. You guys know how this works. You've probably seen it, right? It says rise over run. Yeah, that's the steepness of the line. That means this line we're graphing goes up 3 over 1, up 3 over 1, up 3 over 1. Just keeps doing that forever. So I've already got my 1 dot down here at minus 6. So then I just go up 3 over 1. There's my second. You could get even more dots, but why bother? We got enough. There's our 2 dots. Just connect the dots now. And we've got our line. Is that good? Does that make sense? So you just start at whatever number's off to the right. That's always on the middle line. Positive is up, negative is down. 6. Put your dot. And from that dot, up 3 over 1. That's how you find your second dot. That's the slope, rise over run. Let me show you, if you're good with that, I'm going to flash off of it and show you how you actually do it on the come up with it. All right, so try this one. Pretend the answer's not there. Don't look at it. No, it doesn't matter. But try that. So y equals a half x. There is the answer, but see what you can do. Y equals a half x. I'm supposed to graph that thing. The number, there's no number back here, right? Aren't we supposed to have a number back there?
0.
Yeah, now, what about the fact that I just said, hey, when there's stuff missing, make it 1, and now you're correct to say, no, in this case, make it 0. Well, how do you know? Why, when there's things missing, sometimes we make them 0s, and sometimes we make them 1s? Yeah, it's all about whether it changes. Remember, we're doing plastic surgery, we're making them look different without being different. What if an added number is missing? What number can you add and change nothing? 0. If a multiplied number is missing, what number can you multiply by and change nothing? 1. So that's why if one of these numbers is missing, it's 1. If one of these numbers is missing, we put in a 0. Make sense? You know, what can you add to change nothing? 0. What can you multiply to change nothing? 1. So that's why we do that. Yeah, so just pop a 0 in there and then do the same old thing. So we start. The number at the back is our starter. So we start, that means right in the middle, huh? Start on the middle line at a height of 0. Boom, right there, okay. And now where do we go from there? Well, what's the slope? It says, yeah, rise over run. So go up 1 over 2. So go up 1 over 2. Boom, there it is. Up 1 over 2. And then just connect the dots. And that's what they did right there. Is that good on that? That number at the back missing, it's just a 0. Questions? All right, I'll flash out of Math 201. Like some of you guys took me Summer 201. Some of you guys took me for a couple classes this summer. Anyway, yeah, like not just this, but 60% of this class probably is review. But it's harder. We'll do the same stuff, and then we'll make it a little tougher at the end. And then the last month and a half, 2 months will be new stuff, logs and stuff we've never done before. So yeah, same old stuff, a little harder, a little beefed up, and then new stuff at the end. All right, so how do we graph this one?
You have to get it into y to the next one.
Good. Yeah, did you notice the other ones already had y alone? Let's look back. See how y already was alone? Y equals. One before that, same thing, y equals. Right, so those were easy, those were convenient. So first, get y alone. So this whole process that I've been showing you for graphing only works when you first get y alone. So the other two already had y alone. So you got to get y alone first. Okay, so here's the equal sign. What do I do to get y alone there?
Subtract x.
Yeah, subtract x. Huh? And whatever you do to one side, you know, you got to do it to both sides, because you got to keep the balance, right? They're equal. Left side equals right side, so if you treat them the same, they'll still be equal afterwards,
But
won't they?
that's not really negative. It's going to be negative 1 over 1.
Right. So these cancel, and then we get the y equals. Now, what do we do here? So everybody good so far? On the left side, the x is just canceled out. That got y alone. That's what I want to do, is get y alone. But what's happening I had to do the same thing to both sides to keep the balance. What's happening over here on the right side? Do it. Can I do this, for example? Can I go, okay, negative 2x, like that? Let's talk about why that's wrong. It's important to know why. Not only, I mean, I think most of you know that's not right, but why? Why is that not right? If I write, there's some negative, there's a lot of problems really. First off, two negatives should make positive, that's an issue. But no, even if I made it positive, or just, no sign at all, whatever, it's still wrong. It's still wrong. Why?
Because you're multiplying.
Good. Is everybody seeing that? That's one thing I've noticed that you want to start paying more attention to, that I've noticed students sometimes have trouble with, is thinking about not just the symbols that are there, but what their relationship is. Meaning what's in the middle of them, what's between them. What's between the 2 and the x there? Nothing, which means what? Times. That's times. It was never times. This was adding, subtracting. It can't suddenly become times. So really important to think about how things relate to one another. So it can't become times. So okay, so then what is it? Is it just like minus 2 minus x? Yeah, that's okay. You could do it that way. We like, stylistically, we prefer to put the x first, but that was technically okay. Yeah, they just have to stay separate. We like to put the x first, but you could do the other order. There's no official rule against it. That's fine like that. Now we can graph. Where do we start? Yeah, start the number that's not next to the x, right? Start right there. So that's down 2. Down 2, it's always on the middle line, so down 2. Now we're ready to do the slope thing. We have a negative. Let's just forget about that for now. Let me just get rid of it. I'll put it back in there in a minute. But first off, what about the fact that we don't have any numbers in front of that x? I got to have numbers because I got to have a rise and a run. So, okay, can you just do whatever you want? Like 3, 7? Can I just go, I'll go with 3 over 7. No, that would change it, right? We can't change it. So what numbers can I put in that won't change it? 1 over 1. Because what is 1 divided by 1? And what is 1 times x? No, 1 times x is not 1. It's x. It's still just x, right? So my point is, that's still just x. Now, I know the negative. I'll come back to the negative thing in just a minute. But hold on, I just want to make sure we're clear on the numbers. This is a fancy way of saying x. Isn't it? 1 over 1 is 1. 1 times x is x. I haven't changed anything, really. I've just changed the way it looks. Now, the negative, I know we'll get there. In fact, let me just put it on right now. There we go. So it's negative 1 over 1 times x. That's still negative x. I haven't changed anything. But now I've got a couple numbers I could work with for rise and run, don't I? Now, what could I have made it like 3 over 3? Yeah, of course negative, Yeah, 3 divided by 3 is still 1, and 1 times x is still x. That would actually work. I won't mess with you that way, but it's good. I'm glad you can see that is true. Anyway, back to the negative, because what I really want to talk about, the thing people mess up on is the negative. What about the negative? Now, that negative, where does he go? He's in the front of the fraction, true. So does that mean he goes to the top or the bottom or both or what? What top only or bottom only, but not both. Are you aware of that rule? When you have a negative in front of a fraction, let me just write it over here. When you have a negative, is there room down there? Yeah. You can put it on the top only, I'll say, or you can put it on the bottom only. Why can't you put it on both? Why can't you go negative 1 over negative 1?
Because that would be impossible.
Yeah, 2 negatives would be positive. That's changed it, right? One negative can't be 2 because 2 negatives, that'd be suddenly positive, wouldn't it? That's not right.
If it was on the bottom, you just have to move it to the top, right?
You can actually graph it either way. I'll show. Yeah, so first off, just logically, math is just following the truth logically. 1 minus on a fraction, top only, bottom only, either one's okay. Now, to make life easy, both are true, but what I found is easiest for students, just put it on the top. So I'll just take that minus sign, and I'll just say, look, I'll just put it up here on the top. There we go. Now, you could put it on the bottom, but top's usually easier. So, with that said, let's finish the graphing now. So I've already got my first dot there at negative 2. How do I get to my second dot? This is rise over run. How do you rise negative 1? You go down 1. Down 1 and then over 1. There's my second dot. Connect the dots. I got my line. We're done.
That's your policy, right? To just always attach the negative sign to the top number.
You could put it on the bottom. That's what's
I know,
usually easiest.
But like you always show us.
That's what I always do because it's easiest. Yeah, but let me prove to you that it really would be the same if I put it on the bottom. Because I did say bottom only is okay. So what if you did put it on the bottom? How's that the same? Well, start again from your negative 2. Okay, now the rise is positive 1. So that means up 1.
But you go to the left.
But the run is now negative, which means back 1. And look what happens. You get a different dot, but those 2 dots make the same line as the other 2 dots. It's the same line in the end. Isn't that beautiful? Math always works as long as you follow the logic correctly. So anyway, having said that, I wouldn't mess with that. Just put the minus on the top. It's easier that way. And that way you're always going to the right. You just go down and right or up and right. It's just easier that way. All right. So, okay. So x plus 2y equals 6. All right, let me give you a minute on this one instead of just whipping it out. Go ahead and get y alone. By the way, feel free to bring your laptops, your phones, and get some of your work done during classes. Is fine with me. Once you have a Math Excel account, you can tell to the people that have them before already have their laptop. They know the deal. They're getting their homework done. Great, that's fine with me. If you want to, some people are comfortable enough. You guys are all in different spots. Some of you, this is review and it's easy for you. Some of you, it's been a while and you really need to focus in. Whatever works for you. It's totally fine with me. You want to bring your laptops or your phones and get on the Wi-Fi and just be doing your homework while you see me do one, you go, oh yeah, and then do the one on your homework. It's going to be the same, different numbers. Get half your homework, 2/3 your homework done during these 2 hours. That's fine. Or even on your phone, if you can see those little graphs and things. Some people do that. Better eyes than I got anymore. So get y alone. Let me do that part. What's the first step to get? Maybe it's been a while since you've done some of this. What's the first step to get y alone there? Yeah, subtract that x. Right. You do the adding, subtracting stuff first. And you save the number right next to y. You save that for last. Get rid of that last. So subtract the x from both, so you get 2y. Now again, you could write 6 minus x. That's not wrong. It's okay. But it's usually, stylistically, we usually put the x first. Either way is fine, technically. Like that. But do you see why the 6 is positive, right? There's no sign of 6. He's positive, right? Yeah, I can't make it 6x, because that'd be multiplying, right? That's not right. So now what's the final step to get y alone there? Divide everything by 2. Yeah. And when you divide, you do all 3, don't you? Because there's a left side and a right side. You're dividing all the terms on the left side and all the terms on the right side by 2. If the left side equal the right side and you divide them all by 2, they'll still be equal, right? They're equal before, treat them the same, still going to be equal, aren't they? So these cancel, and so y equals minus x over 2. Just make that a 3, right? Plus 3 there. So y's alone. Go ahead and graph it now.
That's really -1.
Yeah, there's no number up here, right? So just fill in a 1. You know the deal. 1 times x is just x. So just whenever there's a missing multiplied number, fill in a 1.
So could you just write -1/2x? Just to kind of keep it.
Do you mean like, can I put the x in the front? Is that what you mean like that? Because that's okay. Yeah, that's
Just
totally
so
the
that
same
you can
thing.
see the slope.
Yeah, if that helps you. Absolutely the same thing. Yeah, did you guys know that? That's an important, I'm glad you brought that up. That's an important thing to say because on the multiple, we'll take multiple choice tests. What if you were doing something, there'll be things, especially later, where like maybe you have the x in the front and the multiple choice answer has it in the top or vice versa? Would you know those are the same and that you should grab that answer, that's the right answer? Why is it an x alone in the front is the same as an x in the top? I mean, logically, why is that the same? Not just because Mr. Heron says so or some math book. But what do you know logically makes that true? Anything alone is really what? Over 1, isn't it? So it's the same as being in the top, isn't it? Yeah, so to be alone is to be in the top. It's all the same thing. Doesn't matter either way. All right, let's graph it. Where do we start? With the 3. Up 3, 1, 2, 3. Boom, right there. And then... and rise over run. So we're going to rise -1, so go down 1. And then over 2, huh? 1, 2. There's our other dot right there. And then you can just connect the dots. There's our line. Good. Questions on all that? Everybody good? We getting y alone? It's been a while since you've done that. Did I already mention, I think we'll have an assigned class tutor. I'm 99% sure. Have I said that? I forget what I've said. I've done my spiel 3 times today, forgetting which parts I've said. So, all right, so we will very, almost 100% sure, we're going to have a tutor that will visit our class. ETC it's called, Extending the Classroom. So that's a good kind of tutor, meaning they won't show you another way. he works with me all the time. He visits the class every now and then. He'll show you the same ways. He'll have special hours. I'll let you do more getting y alone work. All right, so let's try this one. So 8y plus 4x is negative 4. Same thing, get y alone.
Ooh, can we bypass a lot of things first, or do we have to move it to the other side? This is
Think about dividing 2 by 4?
Yeah.
Yeah, that's a great idea. Do that. I won't show it that way, but that's a better way.
Okay.
I just don't want to confuse people with different methods, but you're seeing that do it. So reduce all your fractions. You know, when you get fractions, 4/8, and reduce those. Reduce those 4/8 to and 8 over 4. You've already got the answer on the screen. It should look like that. So subtract 4x from both sides. Subtract 4x. Those drop out. Then we get, bring this down, 8y. Last step to get y alone. Divide through by 8. And then those are both half, aren't they? You reduce those fractions, divide top and bottom, so we good there. I just divided by 4. Top and bottom like that. Okay, so see if you can graph it from there.
When it gives you negative 1/2 for the y-intercept.
Yeah, what do we do with that?
5.
Exactly.
Okay.
Yeah, so this guy right here, let me talk about that with you. That's where we're going to start. Some people look and go, wait a minute, that's a slope, that's rise and run. Well, no. Just because it's a fraction doesn't mean it's a slope. If it helps you, you could just divide in your calculator and make that minus 0.5. But you don't have to. You could just say, look, it's just down a half a unit. That's all that means, right? So if this is down 1, here's down 0.5. So our first dot, that's a 0.5 there, is down 0.5, or I'll just say half. Either way you want to say it's fine. Down a half a unit. Does that make sense? So remember, this number out here it tells you where the first dot is. I don't use the two numbers separately. They're not a rise and a run. They're just the location of the first dot, down a half a unit. Or down 0.5 if it helps you think about it that way. Either one's fine. And then from there, now we do the rise and run thing. I'm going to take that negative sign, just put it up here in the top, like we always do for fractions, right? And this is rise over run. So I'm going to go down 1. Here's negative 2. So from the starting dot, which is down half a unit, I'm going to go down 1 full jump and over 2, right? How do you go 1? Well, from half mark to half mark, right? So down 1 and then over 2. Here's the other dot. Connect the dots. The line goes forever in both directions. There it is. It looks like, see how theirs is down a half a unit? In the middle. Is that good? Graph and questions I can answer? Let me show you what I'm talking about. So they're giving me y equals negative 3x squared. Y equals negative 3x squared. So they want me to graph it. That's going to be a U-shape. You can tell from all the multiple choice answers already. I don't need to tell you. You're looking at them. They're all U-shape answers. That's because why? What about that equation is making the graph not be a straight line, but instead be a U shape. The x squared, yeah, the second power, right? So if this wasn't here, if it was just regular x, then it would be a straight line, wouldn't it? So, okay, so it's a U shape. Well, how do you find it when it's a U shape? Well, I'm just going to encourage you for now, just make an XY table. Just plug in a couple values, nothing too fancy. In fact, let me move it over here. Later, lot later, like 3 months near the end of the course, we'll do a whole special section on graphing U-shapes, and we'll move them around, and we'll flip them, and we'll turn them sideways even. We'll do fancy things, and we'll get some real particular higher level skills. But for now, let's just plug in some numbers, nothing fancy. How about 0? I'm just picking an easy number. Just 0, 1, 2, whatever. I'm just going to plug in for x and see what happens. So what am I talking about? I'm going to say y equals minus 3 and then x squared, so x is 0. Let me hold on. Does everybody see what we're doing? So the equation is y equals minus 3x squared. In the place of x, I put 0. I'm plugging in x0 in right there. Right? And I'm just going to work it out. What is that? Well, minus 3. 0 squared is 0 times 0 is just 0. Minus 3 times 0, that's just 0. So those two numbers make one dot on the graph, don't they? Are you with me? That's right there. Remember, every one location on the graph involves two numbers, doesn't it? Over and up. So that's 0, 0. That's over 0, up 0. Let's do the next one. How about y equals minus 3, 1 squared? Right now I'm plugging in x is 1. And what do we get? 1 squared is 1. 1 times 1 is 1. Minus 3 times 1? It's just minus 3. So this is, I didn't realize that the graph was going to go down. I should have realized. So this is 0, 0. So this is over 1 down 3, isn't it? You okay with finding the coordinates there? See how I found that dot? Remember how the two numbers with the comma thing work? The first number is over. Second number is up or down. Positive up, negative down. Right? Remember, because x, y. Remember how the two numbers with the comma go? The first is over, so over 1, down 3. Over and then up, down. So over 1, down 3. If I plug in 2, I'm going to get way too low here. 2 squared, that's going to be minus 3 times 4. I'm getting kind of scribbly there. Can you read that? What's that? Minus 12. So over 2, way down here. Can you tell what it's doing? It's just dropping down real quick, right? Can you already tell which graph it is? Is that enough? You just need to do enough to where you can grab the right answer. Can you tell which one it is? Well, yeah, it's already checked, isn't it? That's a silly question. Do you see now it's A, though? Right? It's not B. B's going up. Ours is going down. Now, if you wonder, what about the other side? Well, I just didn't plug in negative values. I could get those values. Do you know what I mean? Maybe I should show you. If you kept going with this table thing, and you plugged in negative 1 and negative 2. See, I just plugged in 0, positive 1. I just picked them. I could have picked any number, right? You pick 17 if you want. You know, any number you can plug in. I just picked easy numbers, so I just did 0, 1, and 2. But you could go back and pick negative 1 and negative 2. Plug those in, and if you did, what you would find, you'd get the dots on the other side. You get the other side of the U shape. So it's answer A. It's not B, because B is going up. Why is it not C? Well, C starts below the middle. See how our graph starts right in the middle? And C is starting below the middle. It's not C. D is starting above the middle. We're starting right on the middle. It's A. So that's exactly the way you'll do it on the multiple choice exam in a few weeks. Is that okay there? You don't have to do this other side. I mean, I could have kept going if you're wondering here. Plug in negative 1, see what will happen. Negative 1 squared, that's positive 1. Negative 3 times positive 1, negative 3. So you see it's back 1, down 3. So it's right there actually. It's back 1, down 3. Etc. You'd get the other side of the graph. The other side of the U shape. Questions on that? Okay, good. So for the ones that are not straight lines, just make an XY table, plug in the easiest numbers you know, 0, 1, and 2. plug them into the equation, get some dots, play connect the dots. That should be enough to figure out which graph it is. They just want to make sure you can do those basic graphing skills.
That's just an absolute value, right?
Mm-hmm. Let's see. So y equals, yeah, those straight lines are absolute value. Those straight lines. Remember what, do you guys know what absolute value does? What does absolute value bars do? Technically it means distance, yeah. It makes the answer positive at the end. That's what those bars do. So plug in, work out the inside, and then the bars, the absolute bars, make answer positive at the end. In other words, you can't make it positive right now. You can't make that a plus sign in the middle right now. That'll mess you up. That's not what it's saying. It's saying once you've plugged in and done all the work and you got your final answer for the inside, then make that positive at the very end. That's what the absolute value bars do. Okay, so anyway, so the point is it's not going to be a straight line. This is another one that's got something weird in it. Are you making sense with me? If they give me a normal equation with x and y, not x squared, not absolute value bars, then I do what we did on those first 5 or 6 problems. I just get y alone, start with the first dot that's on the y-axis, the y-intercept, and then the slope, rise and run. But if they give me something weird, like they give me x squared, or they give me absolute value bars, or something like that, so when it's weird, that's not really technically math, but when it's weird, meaning it's x squared or absolute value, when it's something weird like this, make a table. That's what I'm saying. So make an XY table, put in 0, 1, and 2. Just a good, easy way to start. So if they give you something weird, if they give you something other than just X and Y, regular, no absolute values, no squares, if they give you something weird, then just make a table. So on the weird ones, make an XY table. Plug in 0, 1, and 2. Why those? Because it's just easy. You put any numbers you want in. Those are just the easiest numbers I know. Put in 0, 1, and 2. Where do you put them in? To the original equation. The equation says y equals absolute value of x minus 2. So y equals absolute value of 0 minus 2. Absolute value minus 2. Y is 2. See how it made it positive at the end? See what those absolute values bars did? It turned the negative 2 into positive 2. It makes it positive at the end. Positive 2. Let's do the next one. Plug in 1. Like that for x. I'm just plugging in for x. Right there. And remember, you don't make it plus right now. If you made it plus right now, that'd be 3. That's not right. You first work out the problem, negative 1. Right? 1 minus 2 is negative 1. And then you make the final answer positive, which is positive 1. See how that'd be different than just making the sign plus right away? That would have been 3. It's different. So it's not changing operations in the beginning. It's changing the final answer sign to positive. So it's positive 1. Then we can plug in 2. That's just 0. Huh? Absolute value 0 is just 0. Here we go for that one. So let me come up here and let's graph that thing. So let's just connect the dots on that graph. So where do they go? So first dot is 0, 2. Let's use our table values now. Remember, 2 numbers make 1 dot, don't they? So 0, 2. Remember, it's over and it's up or down. So over 0, up 2. Right there. Over 0, up 2. Good there? And over 1, up 1. Right there. Over 2, up 0, right there. So I've got now it looks, if I just do that, it looks like it's going to be a straight line, doesn't it? But this one's not a straight line. Absolute value is always a V. X squared's a U shape. Absolute value will always be a V graph. It's going to bounce. It can be a V up or a V down. It's going to bounce somewhere. Now, how do you know that? Well, if you wanted, you could do more table making, and you would find that the dots suddenly bounce back up. Let's do a couple more. I'll show you what I mean. So if I went a little further, right, I'm making my table here. If I went a little further with my table, what did I do so far? 0, 1, and 2. If I did like 3 and 4, went a little further, you would see this thing's going to bounce back up. It won't. The line will not keep going down. Let's see it. Plug in 3. What do you get? It's y equals absolute value of x minus 2. So y equals absolute value of 3 minus 2, which is 1. So over 3 up 1. Over 3, kind of getting in the way here. Over 3 up 1's right here. See that? This is over 2 up 0. See how the thing bounced? So that's what I'm saying to you. That absolute value graphs, because it makes everything positive, it doesn't let anything go down below the axis. It bounces it back up like a mirror. Because absolute value says, no, 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 you must come out positive. You're not going negative. You're going to bounce back up positive. So, which answer is it? Well, it's already checked for us, isn't it? It's A. Yeah, there it is. Not good? Does everybody see the big idea, the big plan? If you've got normal x and normal y, just get y alone. Do the y-intercept, the number on the right is your first dot, then the slope, rise and run, for your second dot. But if you got something weird, like that absolute values, or you got x squared, then just make an xy table instead. So we have 2 game plans. That's a lot of the battle in a math class, you know, and doing well on math tests. That's what you want to do for yourself as you get ready, you know, 3 weeks from now or whatever for the exam, is you want to look at that practice exam and think to yourself, okay, when I see this kind of, like a team does for a sporting event, right? You want to think, you know, especially like in something like football, when they run this play, I'm doing that. If I see the quarterback do this, I'm doing that, right? That's kind of the way the math is. When I see regular x, regular y, nothing weird, I'm getting y alone. And then doing my 2 dots. If I see absolute values or x squared, I'm making an xy table. Plugging in 0, 1, 2, right? You want to kind of have a game plan based on the different types of questions you see. Let's go to